In today's episode, you will learn how to request your sensors data from anywhere around the world using GSM. In this tutorial, we will cover number 1, GSM Sim900A module pinouts, number 2, circuit explanation, number 3, interfacing, number 4, programming, and finally number 5, testing. Let's get started. Hi guys, my name is Fahad and welcome to Electronic Clinic. If this is your first time here and you want to learn Arduino, Raspberry Pi, PLC, robotics, desktop application designing, image processing and much more, then start now by subscribing and clicking the bell icon so that you never miss anything. The components that we will be needing for this project are number 1, Arduino or Mega, number 2, GSM Sim900A or Sim900D, number 3, 5V adapter, number 4, LDR, light dependent resistor, number 5, 10K resistor, number 6, some jumper wires, number 7, a variable resistor or potentiometer, and finally number 8, a Vero board, or you can also use a breadboard for the temporary connections. These components can be purchased from Amazon. The components purchase links are given in the description. This is the GSM Sim900A module, but if you want, you can also use GSM Sim900D module. The same code is also tested using Sim900D, but with a different baud rate, while the rest of the program remains the same. This GSM Sim900A module has no onboard voltage regulator, so be very careful while applying the voltage. The ideal voltage for this GSM module is 4.7 volt, but you can also power up this module using 5V adapter. If you don't have a 5V adapter, then you can make your own power supply using LM317 adjustable variable voltage regulator. I have a very detailed tutorial on LM317 explaining everything, so do watch this tutorial. As you can see in the picture, we have so many pins which are labeled, but we will be using only 5 of these pins. The power supply pins, ground, RxD 5V and TXD 5V. The ground will be connected with the Arduino's ground. TXD will be connected with the Arduino's pin number 7 and RxD will be connected with the Arduino's pin number 8. This schematic is designed in Ksoft Eagle 9.1.0 version. If you want to learn how to make schematics and PCBs, then watch my tutorials. The links are given in the description. TX of the Sim900A is connected with pin number 7 of the Arduino. The RX pin of the Sim900A module is connected with pin number 8 of the Arduino, and ground is connected with the Arduino's ground. A power supply is connected with Sim900A. Ideal voltage is 4.7 volt to 5 volt as already explained. An LDR is connected in series with a 10K resistor, which makes a voltage divider circuit. As you know, an LDR is basically a variable resistor whose resistance changes with the amount of light falling on the LDR. So a change in resistance will result in a change in voltage. This change in voltage can be monitored using the analog pin A1 of the Arduino. This is a variable resistor and is connected with the analog pin A2 of the Arduino. As you can see, the LDR and a 10K resistor are connected in series. I have soldered 3 jumper wires. The white wire will be connected with the Arduino's 5V. The gray wire will be connected with analog pin A1 and the black wire will be connected with the ground. I soldered 3 jumper wires with the variable resistor. The red wire will be connected with the Arduino's 5V. The middle wire, which is the white wire, will be connected with the Arduino's analog pin A2, and the gray wire will be connected with the Arduino's ground. This is the complete programming. You can download the circuit diagram and code from a blog page. The link is given in the description. Currently I'm using only one command, which is V. If you want, you can use multiple commands for reading multiple sensors. Hash includes software serial.h. Hash include means that this is a preprocessor directive, and .h means that this is a header file. As you know, my friends, that the GSM Sim900A module communicates with the Arduino through serial communication, and you know that in Arduino we have only one serial port, which is on pin number 0 and pin number 1. As I always say, that use the Arduino's default serial port for the debugging purposes. Now the question is, if we are using the Arduino's default serial port for the debugging purposes, then how we will connect the GSM module? Well, no worries at all. We can define multiple serial ports using software serial library. Character, in character. In character is a variable of the type character, and it will hold the incoming character from the GSM module. Software serial Sim900 7,8 GSM module is connected here. String text for SMS. This is a variable of the type string. Integer LDR is equal to A1. LDR is connected with the analog pin A1 of the Arduino. Integer V resistor is equal to A2. Variable resistor is connected with the analog pin A2 of the Arduino. These two variables of the type integer will be used to store the LDR and variable resistor values. As you know, every Arduino and Mega program has at least two functions, which are the void setup and void loop function. Void means that this function is not returning any value, and the empty parentheses means that this function is not taking any arguments as the input. Then we define baud rates for the serial communication. For Sim900D, I used 19,200 baud rate. Then we use the pin mode functions to set our sensors as input, and then some AD commands to set the message type and delete all the existing messages. As you can see, the functions are well commented. Send SMS function is exactly the same as used in my previous tutorial, which was based on GSM-based laser security system. The link is given in the description if in case you want to watch this tutorial. Then starts a void loop function. If sim900.available equals 0, this instruction means that if the GSM module has not received any message, then simply keep reading the LDR and variable resistor and store the values in LData and VData variables. While these instructions are used to send the census data to the serial monitor for the debugging purposes, if sim900.available greater than 0. This means that if the GSM module has received a message, in our case it will be a single character, read the character and save it in a variable in character. And an if condition to check if the received character is V. If the received character is V, then simply add the census data to the variable text for SMS to make a complete message, and then send this message using the send SMS function. Then we delete the received message, and then at the end we empty the text for SMS variable for the new data. I've already uploaded this program. Let's watch this project in action. All the components are interfaced as per the circuit diagram which I already explained. Power up the GSM module using a 5-volt adapter or any other power supply, but make sure it doesn't exceed 5 volts. As you can see, the LED is blinking fast, which means that the GSM module is not connected with the network. Now, as you can see, the LED is blinking at a slower rate, which means that now this GSM module is connected with the network and is ready to send and receive messages. Now let's power up Arduino. Now type a message consisting of the command V and send it. Wait for a few seconds. As you can see, we have successfully received the sensors data. I hope you liked today's episode. Like and share this video with your friends. See you in next episode and thanks for watching.